Okay, so our special parallelograms. These are parallelograms that have some different unique qualities about them, okay? So our first one that we're going to talk about is the rhombus. We've heard of a rhombus. We may not remember what a rhombus is, but we've heard of a rhombus, right? That's a fairly familiar word, even if we don't know what it is, okay? Easy definition. It is a parallelogram with 4 equal sides. It is a parallelogram with 4 equal sides. Normally, our parallelograms just have the top 2 sides are equal and then the other 2 sides are equal, right? Here, they're all going to be equal, okay? So, the best, let me try to draw a parallelogram. Do those 2 sides look about equal? Pretty good to me, maybe a little bit longer. That might be too long. Okay, so these 2 sides are equal. Now I'm going to try to make the rest of them equal. All right, and you remember how we show that things are equal. We put 1 tick mark for all of them. Obviously, if it's a parallelogram, these are equal, right? Why is that obvious? Because on a parallelogram, the opposite sides are equal, right? These are equal. And these also are equal. So in this case, all 4 of them are equal. For a rhombus, all 4 sides are equal.
I thought a rhombus was a diamond.
I mean, we generally, we draw them like diamonds, but it doesn't have to look like that. Like if I turn it this way, it's not a very good drawing, but it kind of looks like a diamond. Here, I'll draw another one for you. Man, I am struggling with this. As long as all 4 of them are equal to each other, it's a rhombus, okay? So you're probably used to seeing it like that, but it doesn't have to look like that. It can look like this. So, because this is a parallelogram, the things that we talked about yesterday are still true, okay? And I'm going to abbreviate. The opposite sides are still equal because it's a parallelogram. The opposite angles are still equal because it's a parallelogram. And the third one, which is our weird one, that is that the consecutive angles add to 180. Okay, these are our 3 properties of parallelograms. They must also be true for a rhombus. Okay, so far, these are the 3 things we talked about yesterday. These are true for any parallelogram. If they're true for any parallelogram, do you think they're true for a rhombus? Yeah, they are, because a rhombus is a kind of parallelogram. All right, so that's our first one. Our special parallelogram is a rhombus. A rhombus is when all of the sides are equal, not just the opposite sides, but all of them. All right, our next one, and I know we're familiar with this one, is a rectangle. Now I know we know what a rectangle looks like, but I wonder if we can define a rectangle. Okay, first of all, I'm going to give you a hint. The first part is it's a parallelogram. But more specifically, What's so special about a rectangle? What makes a rectangle a rectangle? Got four sides, that makes it a quadrilateral, a parallelogram. But not every parallelogram is a rectangle, right? Not every parallelogram is a rectangle. What makes certain ones be a rectangle? Okay, it's tilted. How far do we tilt it until its angles are what? No? No? It is a parallelogram with four right angles. I really think we probably should have known that. So a rectangle is not just a parallelogram, it's a parallelogram where all of the angles are right angles. So instead of our parallelogram being tilted to the side, this one's more straight, okay? We know what rectangles look like. You guys know this. Here, here, so that all of our angles are 90-degree angles. Now think about this. Like, actually think. Don't just zone out now, because that's what you guys do. Since this is a parallelogram, are the opposite sides equal? Yeah, they are equal. Are these sides equal? Yeah, they're equal. Okay? Since it's a parallelogram, are these lines here parallel? The top and bottom? Yeah. Are these lines parallel? Yeah. All of the stuff that we know about parallelograms are true for rectangles. They just also have to have four right angles. Okay? So instead of rewriting them again, actually I think I'm going to write them again. The opposite sides are equal. The opposite angles are equal. And the third, the weird one, is also true. Consecutive angles add to 180. Again, this is for any parallelogram. So that means it also applies to rectangles. All right, I want to look specifically at this third one that we talked about here. Consecutive angles, that's two angles in a row. Add to 180. Well, on a rectangle, all the angles are how many degrees? Each one is how many? 90. So if two of them in a row, like this one plus this one, what's 90 plus 90? 180. What's 90 plus 90? So it still applies, okay? It still applies because 90 plus 90 is 180. All right, so we got our rhombus. That just means all four sides are equal. We got our rectangle. All four angles are equal, aren't they? And they're also 90 degrees. Now our last one. Any guesses what our last one's going to be? A square, exactly right. So your square is our last special parallelogram. And a square is extra special. It is extra special because it is a parallelogram with two important attributes. What do we know about the sides of a square? They're all equal. What do we know about the angles of a square? Each one of them is how many? 90 degrees. So that's the two things. A square is a parallelogram with four equal sides. Look, if I stop right there, if I stop my definition right here, what would I have? No? A parallelogram with four equal sides? I'd have a rhombus, right? That's what we just wrote up top. So if I stopped here, I'd have a rhombus. So you know what that means a square fits under the category of? It's a rhombus, okay? So it is a parallelogram with 4 equal sides, but it's also and 4 right angles. Well, where does the 4 right angles come from? The rectangle one, right? So what this means is your square, not only is it a parallelogram, this part makes it a rhombus, and this part makes it a rectangle. Okay, let's draw a square real quick. All of the angles are 90 degrees, and all of the sides are equal to each other. Okay, so one more thing I want to write here is what I was just saying. Not only is it a parallelogram, a square is also a rhombus and a rectangle. This part of the definition makes it a rhombus. This part of the definition makes it a rectangle. So, any of you guys have seen this, but under this web, quadrilaterals, that's the main thing we're talking about. Anything with 4 sides. Anything with 4 sides is a quadrilateral. Yesterday we talked about parallelograms. Parallelograms fall under this category, right? Do parallelograms have 4 sides? Yeah, so they are quadrilaterals. Now today we've added to this some special parallelograms. They go under here. So the first one we did was a rhombus. Now think about it. A rhombus falls under this category, which also falls under that category. And then we talked about rectangles. And then lastly, like he said, if a rhombus and a rectangle had a baby, it would come out as a square. And I want you to see this. A square is a rhombus. A square also falls under the rectangle category. It also falls under the parallelogram category. And it also falls under the quadrilateral category. I don't think I can zoom out to look at all of it at once. Yeah, I can. So there's, now think about this. Tomorrow, no, not tomorrow, in a couple of days, we're going to talk about some quadrilaterals that aren't parallelograms. So they're going to branch off over here, okay? Some things that don't fall under this category. So do not lose this page. We're going to come back to this map and we're going to fill in what goes over here on this side, okay?